Welcome back, friends. So in this video we will be working on project number 18, that is rainfall prediction using random forest. And for this project we will be using the data set provided by Kaggle, and this data has total of 12 columns, and the link of the data set I will be providing in the description below. Now coming back to our project, let's first import all the libraries. First we will import NumPy, import pandas, spd, then we import from sklearn dot model selection, import train test split, then we will import resample from sklearn dot utils, import resample, then we will import accuracy score from sklearn dot matrix, import accuracy score, then we will import random forest classifier. So we will write from sklearn dot ensemble, import, we also need standard scalar, yes, then we will import matplot library as plt and sns, and that's all. Yeah, let me run it. So NumPy, what is NumPy? NumPy is used to create arrays and manipulating any arrays. That's the job of the NumPy. And then we have pandas that will be used to convert our data set into pandas data frame. Then we have train test split that will be used to split our data into test and training data set. Then we have resample is used to basically convert our data, or basically it is used to downsample the data, downsample or vice versa. Then we have accuracy score that will be used to predict the accuracy of our model. Then we have random forest classifier that will be used to train our model. Then we have standard scalar, it is used to standardize the data in a same scale. Then matplot and seaborn are used to plot graphs. Okay, so first what will we do? We will do data collection. So I will name it as rainfall data. Rainfall data is equals to pandas dot read csv, and name of the file. I have already uploaded the file rainfall.csv. You can upload from this button, and you can download from here, this button. Okay, now let me paste the name rainfall.csv. So our data has loaded into rainfall data. Now let's print the first 5 rows. Rainfall data dot head. So we have first 5 rows. I can see there is a text form of data rainfall which we need to convert into numerical form, because model only understand numerical values. So we will convert it. Let's print the number of rows and columns. So rainfall data dot shape, so it will print the number of rows and columns. Let me print the basic information about the data set. So we will write rainfall data dot info. It will tell the it's a function, yeah, it will tell us the data type of the column and number of values it has. So First one is of integer type, and we can see object that we will need to convert into numerical form. Let's check for the missing values. So first, we also need to do one thing. I can see that in this wind direction column there is a space, so we need to fix it. So what we can do, we will write rainfall data dot columns is equals to rainfall data dot columns dot string dot replace, not, I don't need str dot strip. So what it will do, it will remove all the spaces in the columns. So let's run it. After checking, let's print info again just to check whether the wind direction has updated or not. So as we can see, all the spaces have been removed. Now what we can do, we will check for missing values. So for that we will write rainfall data dot is null dot sum. So we have two missing values. The first one is the wind direction and the second one is the wind speed. So wind direction and wind speed, we have one missing values. Okay, and I can also see that we don't need day 1 2 3, but we do not require day. So what I can do, I can drop day column, drop take column, and rainfall data is equals to rainfall data dot drop day column, yeah, with access 1 is column. Okay, so day is not here. What it says, it is small d. Okay, so I dropped it. Now let's print first 5 rows again just to check. Rainfall data dot head. So day column has been removed. Now I have to fix missing values in wind direction and wind speed. So what I can do, first I need to check the number of unique values in the wind direction, that and then I can analyze it. So rainfall data wind speed, let's go for first wind direction dot unique values dot unique. So we have 80 50 40 20, all the values are the multiple of tens, and there is one missing values and n, not a number. So what I can do, I can replace the missing values with the mode of the wind direction. Okay, so rainfall, let me write a comment, handling missing values of wind direction with mode wi with mode. So rainfall data wind direction dot fill na, it's, yeah, great. Now I will handle missing values of wind speed with the mean. Handling missing values of wind speed with mean. Rainfall data wind speed. So why I use mode, just because all the values were in are the multiples of 10. If I use the mean, so I might get the values in which would not be in the multiple of 10. so I used the mode, and for the mean I used for the wind speed I used the mean. Okay, let's check for missing values again. So what I can rainfall data dot is null sum. So in our data set we don't have any missing values now. Now what I can do, I can replace the text data in uh, in rainfall with numerical values. Okay, so rainfall data, the column is rainfall, is equals to rainfall data fill, no, this one dot replace. First I need rainfall dot replace. I have to replace yes with 1 and no with 0. Let's do it. Now let's check the output. Rainfall data dot head by printing the first 5 rows. So our data has been updated. So first 5 values are of have yes. Okay, good. Now we will see the distribution of the output target column. Rainfall data, when we have rainfall dot value counts. So we have 249 records with target column 1 and 117 records with target 0. So one means that there will be rainfall and 0 means there will not be rainfall. Now what we can do, we can visualize our data. So for that, what I need to do, first I need to set my nss dot set. Let's say style as while grid. We don't need this now. Let me set it first. Okay, it's done. Now let's see the correlation first. So plt dot figure fix size is equals to, let's say, 10 by 8. 10 by 8 is good. X is equals to, we will show the heat map, sns dot heat map, and we have data as rainfall data dot correlation, correlation, and not is true. cmap is equals to, let's say, cool warm, and fmt is equals to, let's say, 0.1 is good enough, and then plt dot title, let's make a title as correlation correlation heat map plt. So it will give a correlation heat map. So before explaining, let me explain what is correlation. So correlation defines the relationship between the two entities. There are two types of correlation. The first one is the positive correlation. The second one is the negative correlation. Positive correlation defines if one entity is increasing, the other entity will also increase by some rate. For example, if area of land is increasing, so it is proportionate to the price, so the price will also increase. And same goes with the case of negative correlation. If one entity is decreasing, the other will also decrease. So So if negative means if one entity is increases, the other will decrease. That is the negative correlation example. So first line defines the size of the correlation. The second one defines the correlation. Then we pass n out to n out is equals to 2. That defines that you have to write you have to fill the values inside the box. And cmap coolform, that is the theme of this map. Then fmt point 1 defines the after how many values you can see after decimal. So title is correlation heat map and plt show to show the graph. Now what we can do, we can analyze it. We can see all the elements in the diagonals are correlated by 1. That means the pressure is correlated to pressure by rate of 1, and same goes with the same goes with the other entities as well. Now we can also see that maximum temperature is negatively correlated with pressure. Temperature is also negatively correlated with pressure. Minimum is also correlated with pressure. So these are kind of same. So max temperature, and minimum temperature, these are heavily correlated with each other. We can, so next what we can do, we can plot box plots. So for that, what I can do, plt.figure size is, let me increase by 1510. Now what I can do, I will create a for loop for I in column in enumerate, and I will define all the columns. So first one will be the pressure, the second one will be the max temp, the third one is the temperature, TEMPERTUR temperature, the fourth one is minimum temperature, humidity, we have wind speed, we have also cloud, sunshine, in single commas. Yeah, now and it's a plot as, let's make it 3 comma 3 comma I, and blocks plot rainfall data, that is good. Then we have title as column, then we will write plt plot dot tight layout. Okay, what it says, we have pressure 1 2 3 4. We also need to include dew point, humidity, then we have cloud, then sunshine. It should run now or not. How many columns are there? There would be 11 columns now. 1 2 3 4 5 6 7 8 9. So there was an error. You should start from 1 instead of 0, so you have to correct the I plus 1. And also the spelling of the temperature should be TEMPAR, not ERA. So in this data set, the spelling is ARA. Okay, so keep in mind, after running it, you will see a box plot. So what is a box plot and how to read this graph? So let me tell. You can see that this value defines the 25% percentile, or you can say Q1, and this one represents 75 percentile, or you can say Q3. That means uh, Q1, that means 25% of the value is less the than this value, and 75% of the value is less than this. And whatever you see here, these are known as the outliners. So what are outliners? Outliners are any data points which are beyond Q3 plus 1.5 IQR, that is known as the outliners. So this is the basic formula: Q3 plus 1.5 of IQR. And uh, and for this, if n outliner is here in the left hand side, as you can see here, so it will be calculated by q1 minus 1.5 multiplied by iqr, and iqr is this length, is known as iqr. Okay, or you can say interquartile range. Okay, so we can see there are two outliners, and uh, in dew point there are five outliners, and in humidity there are 6 to 8 outliners are there. Same goes with the wind. Wind has four outliners. Now, what we can see, I can see in this correlate graph we analyzed earlier, these three columns were highly correlated: max temperature and minimum temperature. So what I can do, I can drop these because they are highly correlated. So we will drop it. We'll drop uh, temp ARA. So we need rainfall temperature. Yeah. Now we dropped all these columns. Now let's analyze the distribution of target column again, because now we will be doing downsampling. Value COU and counts. So there are 249 with target column with target value as 1, and 117 with target column 0. We will separate them. Let's say data frame majority is equals to rainfall data with rainfall data not there, so rainfall we will place it 1 and it is 0. Okay, let's print df majority and print int df minority. We can see that all the values with target column 1 are in the df majority, and all the values with target output as 0 are in the df minority. Now what we can do, and also to mention one thing, that df majority has 249 columns and df minority has 117. You can check by printing the shape. So df majority dot shape and df minority dot shape. Yeah. Now what we'll do, we will do downsampling. Okay, so as we can see, the gap is the difference between df majority and df minority is very high. So what we will do, we will reduce 249 values to 117, so that our data sets becomes equal. Okay, so downsampling, sampling, downsampling majority class. Okay, so we will do df majority downsampled. It's good. So our data set was df majority replaces false and samples is equals to length of the minority, that is 170, and random state is 42. You can write any value you want. It is uh, just to fix that the randomness of the records is matches with the other teammates when you are working. Okay, that doesn't define anything in our project. Okay, let's print uh, the shape just to check how many. We don't, it's not a function, just it is a method. So we can see that after downsampling we have 117 records. Now what I can do, I can append my df minority and df majority downsample just to make a common data set. So I will name it as df downsampled as dap pandas.concatenate majority. Yeah, it is correct. Let's print the shape again, df. So we have total of 234 records now. It is 117 plus 170 is 234. Let's print the first 5 rows, df downsample dot head. So the first 5 rows are 1 because we appended majority then minority, that is why we have the first 5 rows as 1. So what I can do, I can see that first 117 records have the output 1 and rest as 0, so I can shuffle it. How can I do that? df downsample is equals to df downsample dot sample frac is equals to 1, random state as 42 dot reset index, and drop is equals to true. So what it does, so sample is used to randomly select rows from a data, and frac is equals to 1 means selecting 100% of the data, and random state 42 ensures that the shuffle is reproducible, and we are removing the old index. So if I print it again, so it will say print df downsample dot head. Now it should be mixed, yeah. So we shuffle the data. Now we will split our data into features and target. So X will contain all the features and Y will contain the target column. Let's print X and Y. Now we'll split the data into target column and test data. Sorry, training and test data. X train, X test, Y train, Y test is equals to train test split. We have two original data sets, X and Y, and test size 02. let's print the number of rows. Yeah, so initially we had 234 rows. After splitting into 80 and 20, training data set contains 187 uh, records, and test data set contains 47 records. Now we will do model training. So first we will initialize our model. So model is equals to a random forest classifier with random state as 42, random state as 42. I will explain. Then we have hyperparameters, parameter grim, param grid, grid, pa. Okay, so n estimators, let's go with 100, 200 and 300. Then we have x depth, max depth, minimum sample leaves, and maximum max features. Let's add max features. Features should be sqrt log 2, and 0.5. What else do we need? Next step should be not that much, 5 and 10 should be enough. Max features, then we have max minimum sample split should be 2, 5, 10. That's good. Then we have minimum sample leaf should be 1 to 4. So it defines, and estimate defines how many branches can we make, and depth is to how many depth, like from, and then basically it's unlimited. 5 means up to 5 depth we can analyze our answer. Up to 10 depth we can analyze our data, our output. More the depth, more time it will take to train our model. And max features, that how many features can we take at a time. So sqrt matlab sqrt of 7, so we can take around 2 to 3 features at a time. And log 2 of how many features, and 0.5 means 50% of the features we are taking. So minimum sample split, that how many split can we do from the internal node. First we did 2, then 5, then 10. And minimum sample leaf, that how many leaf should how many leaf should be there at the end. That's 1, 2 and 4. Now we will hyper tune our grid search. So grid search, grid search CV, estimator is equals to model, param grid is equals to, yeah, param grids CV is 5 and jobs is equals to -1 plus 2. Great. Then we will do grid search dot fit. We are training our model. We will not print it here, we will print at the end. So it will take some time. So grid search CV is not defined. I think I forgot to add data split and grid search CV. We also need crosswells for, just run it. We are good to run that cell. So white is capital Y. So we are using grid search to try different combinations of this parameter. It will take some time. So while it is running, so what I can do, I can write the code for model evaluation. It will CV score is equals to cross well score. Just a minute, I have to put it to a variable CV. Score is equals to cross well score best RF model. I have to define the RF model. Okay, just do I have to define best RF model. RF model is equals to grid search dot best estimator then we'll print best RF model. So what I'm doing, uh, from these all the parameters we will get the best model and we will print it here. So around after 5 minutes the RF model has been trained. And just to give you a pro tip, you can change the runtime to T4. So click on runtime, change runtime and click on T4 GPU and then save it. And after that you can run all, click on run all to execute all the commands again, and it will be quicker than the normal CPU. Then after that we calculated the best model using CV score, and the best model is coming out to be with minimum leaf sample 4, minimum split sample 10 and random seed 42. Okay, now we will do model evaluation. So for that what I can do, I just need to, this is the same code above, let me just erase it. So for model evaluation, let me print the CV score. CV score is equals to cross well score and best RF model. CV is 5, then we'll print CV score, and I will also print CV score, yeah, numpy dot mean CV score. So these are the score after cross validation, and its mean is coming out to be 0.76. So anything above 70% is considered as good. Now we will do it same for the test data. Test set performance vibrate is equals to bar star accuracy score void test and vibrate. Then I will print the accuracy. Accuracy is coming at 80%. That is good. Now we will do prediction on unknown data. My prediction on unknown data, input data, let it be empty for a while, input data frame is equals to pandas dot data frame input data, and in the data frame what I can do, I can define the columns, so they will be correlated. Columns is equals to, we have pressure, then we have dew point, in dew point, then we have humidity, comma humidity, then we have cloud, so cloud will come here, Control X, Control V, cloud, then we have sunshine, cloud, then sunshine, then wind direction and wind speed, wind direction and wind speed. Okay. So these all are the values. Now next, what I can do, I will print the input data frame just to double check, and I need to write input data. For that I will take, let's take the first one first. Okay, let's take the first one. Pressure, dew point, humidity, rainfall, we have to erase it, sunshine, we have to remove rainfall. Okay, comma, 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 remove it, comma, comma, let's print it. So we have total of 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Did I miss something? 2 3 4 5 6 7. 1 2 3 4 5 6 7. What I did, data frame. So there was an error, I forgot to add a comma here, so we should run now. Yeah, now we will do prediction. Prediction is equals to best rainforest model dot predict, then we have input data frame, we will print prediction. If our prediction is prediction of 0, so it is coming out to be 1, it will rain tomorrow, and we choose the first one. Yeah, it is 1, so it will rain tomorrow, so our model is correct. And if you have any problem regarding this project, do let me know in the comment section, and don't forget to like and subscribe. Thank you.